very small font. I could not recognize. This is the example which I discussed yesterday. You see? This is a dendrite. Yes? This is a dendrite. And here you have 1, 2, 3, 4, 5, 6 copies of this dendrite, and they intersect in this black subdendrite. So how it was constructed? I had some kind of family of hexagons, but it can be extended to a family of pentagons with regular pentagons with 12 sides. So this dendrite is a subdendrite of a large dendrite with 12 branches, yes? So if we take this initial one and properly rotate its copies here we'll have the images of these copies will just sum up to this 12-sided, 12-branched dendrite, yes? But they are organized in such a way that they intersect in this subdendrite with 6 branches. So such is a nice construction, but I will explain to you how you can construct dendrites from polygons. So suppose you have a triangle, yes? If you have a triangle, you can draw some number of triangles inside it, yes? In such a way that any of them have one common point, and this point is a vertex. Yes, then if you take the system S1, S2, S3, and S4, which sends the larger triangle to triangle 1, 2, 3, and 4, yes, then the attractor of this system will lie inside this triangle, first. Second, the vertices will belong to the attractor. The attractor will be connected because the intersection graph is connected, and it will be a dendrite because the intersection graph is a tree, right? The attractor will be a dendrite. So initially it was proved in more complicated manner, but now it is very, as usual, everything becomes simple with the course of time, except the theorem about open set condition. Okay, so we can construct such a system, yes, and build its attractor. But if you have a dendrite, in a dendrite, any two points can be connected by unique arc. So if we connect the vertices of the triangle by this arc, we'll get a main tree of this dendrite. It is a main tree. Maybe this picture is quite complicated, but if you consider a Wittig set, you see the Wittig set, which is formed by 5 maps, 5 homotopes, which send the square to small squares. Yes. Then you will see that the main tree will be such a cross. Yes. And if you consider the images of this main tree, then you will have the images of this cross, many, so it will remind us the graph of a group, yes, of okay, so if you consider this main tree will, the images of this main tree will cover the whole set of cut points in the dendrite. Because if you have a dendrite, there are two kinds of points. There are end points and cut points. This is very interesting. What is the dimension of this figure? Can you find the dimension of this set? Suppose that all these numbers are 1/3, 1/3, 1/3, right? So you have 5 copies with coefficient of 1/3, and 5 multiplied by 1/3 to the power of s should be equal to 1, right? Therefore, 3 to the power of s is equal to 5, and s is logarithm of 5 with respect to 3. So dimension can be found quite easily in this case, because this is a very special case in which dimension is easy to find. Okay. Now, and what's about the main tree? The main tree consists of straight lines, right? Therefore, if we have a main tree and if we take the set of cut points in this dendrite, it will be a countable union of these lines, right? Therefore, it has dimension 1. You see, the dimension of the main tree is equal to 1, and dimension of the whole dendrite is equal to logarithm of 5 with respect to 3. So this dendrite is easy to be constructed, yes, and we can you try to do this? Is it possible for you to create this picture in your laptops? Or do you have such a possibility? Or you are deprived of this possibility? You have no laptop. Huh? Oh yes, together it will be easier to do everything. So just try to construct what are you thinking about? Do you need any help in constructing these maps? So you have a polygon, yes, and you have its image. So maps are very simple, right? So what is this map? S1 of x. So if this is 0, this is 1, 0, and this is 1, 1, and this is 0, 1, yes? So S1 of x will be x divided by 3, right? And all the others will be obtained from this x divided by 3 by translation. So you can write that k equals what? 1/3 multiplied by union identity union 2, 0, because this 2/3, yes, union 0, 2, union 2, 2, and union 1, 1, 1, 1, multiplied by k. Am I right? Okay. So maybe the number smaller. For assignments, it's too much. It's okay? Yes. Yes. But how to build this main tree? The main tree is more complicated thing because it consists of several arcs. You see, this arc and this arc. In this case, these are two arcs. Yes? Yes, it is easy because these are lines and this is not a problem. But now let us consider the second example. I take a triangle, yes, take some Q, it is the same, and then draw this one triangle inside, yes? How to construct this attractor? So you need to compute these points, right? These points. And you need to compute this rotation. So you need to know this interval, yes? And if you take this 1, 0, 0, and 1, 0. Yes? So you need to define the map which sends this interval to this, this, and this. So first you need to find these three coordinates, and you need to know this coordinate and this, the length of this, and the coordinates of this interval. Yes? Right? Okay. So can you find these numbers? So if you have Q, you have Q, and you have this. Do you need help, or it's easy for you to find these numbers? So let us look. This point is 0, 0. This is, what is this coordinate? Q0. Right? What is this coordinate? Can you find this one? This is Q divided by 2. So first coordinate is 1 minus Q divided by 2. And second, Q square root of 3 divided by 2. Right? And also we need this point. This point, what it will be? 1 minus Q multiplied by square root of, 1 minus Q, 1 minus Q divided by 2, right? And 1 minus Q square root of 3 divided by 2. This is that point. What? Oh, please repeat.
This coordinate is Q, first coordinate.
Not. This is coordinate is 1 minus Q divided by 2. Because the cosine of pi divided by 3 is 1/2. So you see, you have, this is unit interval, right? And this interval has length 1 minus Q, right? And if you project it, you see this picture is wrong. If you have different Q, this triangle will be rotated at different angle. Please look. If Q is small, then you have, do you see? This is not a vertical, so this point has, you have 60 degrees angle, yes? This is, the length of this interval is 1, and the length of this one is 1 minus Q, because this is Q. So it will be 1 minus Q divided by 2. And this coordinate will be 1 minus Q multiplied by square root of 3 divided by 2. Yes? So you have these coordinates. And These coordinates, you know this coordinate? Yes. This you know, this one you know. It's 1 minus q0. Q0. So let us draw the system. What system will give us this attractor? So this triangle is contracted q times. So you will have k equals q sorry, first we need to write translations. 1 minus q 0, and this coordinate y minus q divided by 2, 1 minus q divided by 2 square root of 3. Yes, and it will be multiplied by q. And this map is a map which sends 0, 0, 1, 0 to these 2 points, right? These 2 points. So it will be SIM, and you take this coordinates q0 and this one SIM of q0, what? 1 minus q divided by 2, 1 minus q divided by 2, 1 minus q divided by 2, and q square root of 3 divided by 2. And if you write this way, then you will get the attractor. Yes? So please, of course you need to define q. So q will be a number. This number will be real, and it's better if it's less than 1/2 and more than 0. But let us take it between 0 and say 0.4. Zero is too small. Let it be between 0.1 and 0.4. Not very small and not very great, because if you put the value 0, sometimes you will get the number is chosen randomly, therefore some pictures will be not good. So we suppose to give you some assignments today in the evening, so that you could do it till tomorrow. And this will be assignments to build something, to build some models, and to find dimensions or find equations for them if So is that okay? It's very interesting, yes. If you have some problems, I will, after you construct this example, then we'll discuss one more question concerning this self-similar set. Does it work? What?
Showing no errors, but when applied, it is not showing.
Yes. The problem is that where is your equation? 1, 1 minus q0, 1 minus q divided by 2, 1 minus q multiplied by 3 to the power 1/2 divided by 2, it's okay, multiplied by q, and SIM and q, and what it is not shown up. Wow. Okay. Because I said it must be between 0.1 and 0.4. If you take 0, it cannot construct anything because the mappings will not be contractions. Yes, nobody knows what danger. Sorry. Yes, again. No, it doesn't show. 1 second. Wow. How did you? Yes, it's like this, yes. But I have more interesting problem. The main problem is to find a mistake. It's a real. There is some invisible mistake. Number real. Yes, it's okay. K. Because it doesn't say about.
Yeah, it doesn't still make sense.
And 3 times 5 divided by 2 SIM. And did you define SIM?
Yeah, I did it. First of all, the error showed up, then later I did it.
So you know, you have it.
Yes.
Maybe you can check, compare your program with some. So did you succeed?
No, sir. I'm just trying.
Just try. It also doesn't work. Oh, excuse me, please, can you give us advice? Because, yes, oh, this is good. Because, can you compare the codes here and there? I cannot see any mistake. I cannot see. No, this should be connected. Some mistake. 1 minus q divided by 2. Q. Oh, really? Q or maybe q square root of 3 divided by 2, right? Y minus q divided by 2. Let us check the following way. So you have some kind of a mistake which is invisible, yes? But maybe you see you have this very interesting triangle, right?
फाइल में डाले हो ना
It's kind of rotating type.
One third, one, no, KK1,
हाँ कि कोई यहाँ यूज
one.
करते हो
सेम सेम यूज हो रहा है ना
So,
वैसे करके देखता हूँ.
so if you put here, uh, please print define interval, okay? So define interval, you know, unit interval, and then put it here instead of KK, and look what will happen. Yes, yes, you are perfect. You are perfect, and you too, I suppose.
यहाँ भी क्यों
So did you? Oh, very strange. You have nice curve, but not of that sort. So let us wait for the result. Did you succeed? This is okay, but the second is not.
The second one is not running actually. I
Maybe,
tried many times. Now
maybe I.
writing the code again.
You're writing the code.
Because maybe there is some error.
So maybe I made some mistake here on the blackboard. How do you think?
no it's fine
It's fine. But why it happens that one person does prints these letters and everything works, and the other person prints the same letters but nothing works? Of it. So did you?
The same problem I am
नहीं हो रहा
having. Same problem.
So, yes. Computers are very sensitive. Yes, it depends on who. If one comes to this computer, it begins to work. Then if so, did you succeed? And did you try? Let me. But SIMQ. You need to print different. You have Q011, but here you have. So let me draw these letters in greater scale. So I will enlarge this picture. Maybe it was because I was writing the letters in some improper way. Minus Q 0 union. Here you have 1 minus Q divided by 2. 1 minus Q divided by 2 multiplied by square root of 3, right? And it is multiplied by Q. And all these things are in parentheses. And the second part of the union is SIM. Here you have Q 0, 1 minus Q divided by 2, Q square root of 3 divided by 2, all this closed, and then all these parentheses are closed, and it is multiplied by k. Yes, I write it in greater letters. What? It works? Almost works, but can you enlarge? There are two problems for me, not for you. One problem's very small letters, and second that they are very dark. Oh, sorry. Okay. Let us return back to editor. Yes. And let us compare what is 0.87?
Root 3 by 2.
Square root of 3 divided by 2. Just write it exactly. Because otherwise there will be a gap between points, you see. Just write square root of 3 divided by 2. Yes?
I want to understand, sir, that triangle, actually what you were trying to do actually, this triangle you made, no?
Yes?
Yeah, so what was the S1, S2, can you just...
S1, S2, S3,
Yeah,
S4. So, I grouped. This is S1, 1 and Q. This is S2. This translation multiplied by this contraction. And this is S3 and this is S4. So, did I answer your question? Okay. So did you succeed? Oh, it's okay. This is wonderful. So, do you know how to find the dimension of this,
The vertices?
of the attractor?
Okay, no sir.
Yes, it is very simple. Oh, sorry.
Okay.
It is here. Of course, you can solve an equation, but fortunately, this program finds dimensions very well. So, can you switch from dark theme to black and white and black? I don't know, but usually I have white screen and black letters. Yes.
Overall system की thinking.
Or you need to. So you found the. And did you? So, did you succeed finally? Oh. And nobody can help you. So you both are in danger.
Yes.
You are okay.
I also got.
And you too. Oh, that's wonderful. So can we proceed? We need to make one more thing, and it needs some explanation. Because if you have an attractor, if you have a dendrite, you need to find its main trees. Tree. So, at some moment we need to proceed to the next step. Yes? So, please raise your hand who cannot construct this figure. How many people didn't construct? 1, 2. Yes. So you have some mistake or yes. Q number real 0.1 number real, and what is the union sign? Delete this union sign. Okay. Error. Oh, one more error. So there may be Q. And what is Q3? Q multiplied by 3 to the power. You forgot the multiplication because the program considers as Q3 one more name. Again, you need to look carefully. And what is this? 2 point, what is it? Between 2 and this comma? Comma. Yes, comma, then please check. Can you enlarge this scale and return back? Okay, because I cannot. 1 minus Q. Sorry, 1 minus Q. What is 1 minus Q? I don't understand. Where is 1 minus Q? There is some strange expression on your. This is. Please compare what you printed and what is written in your. So you are okay?
Yes, I got it.
Yes. I'm very sorry, but I need to proceed to the next stage. Yes. Initially, I supposed to come with one of my former students and now colleague who could serve as assistant, but he was rejected the visa by some unknown reason. Yes. Yes. If we were two, then we might be able to check all mistakes, because checking mistakes is a very difficult task, as you understand. So our problem is to find. So if you have this attractor, you have the main tree, which goes something like that. You see? If you have a dendrite, then its vertices, there is a minimal subdendrite containing all its vertices, and it will be a tree, topological tree. And we need to find this main tree. We need to find this main tree equations. So we need to write these parts. So all these branches of the, since this case is symmetric, then we have a curve gamma, which consists of this part, this part, this and this part. And all this, and this is also the same curve gamma, rotated by some angle. So we can write the equation for this gamma. So let this curve be denoted by gamma. Gamma. Then we'll see that gamma is equal to one image of gamma, second image of gamma, and third image of gamma. Yes? So it will be, if this is S1, so gamma will be equal to S1 of gamma, right? Union the image of gamma under rotation by the angle 2 pi divided by 3 with respect to the center of this triangle. Yes? How to rotate a triangle by 120 degrees? You can rotate it, if this point is 0, you need to rotate it 120 degrees and then to translate it by 1. Okay, so let R will be a composition of translation by 1 and rotation by the angle 2 pi divided by 3. So it will be S1 of gamma union S1 multiplied by R multiplied by gamma. So it will be S1 multiplied by gamma union S1 multiplied by 1 by R of gamma. Yes, our union is drawn this way, and then you have, and this is S1, S2, S3, and this is S4, and union S4 at gamma. So if you write this equation, you will get this part of this curve. Yes. And suppose to make the whole main tree, then you will get 3 will be equal to 1 R multiplied by R and multiplied by gamma. So this will give us the main tree of the dendrite. Did you understand how it was done? No? So we have the main tree. It consists of three symmetric curves. Right? So we denote this part of curve by gamma. Yes? And notice that this part of gamma is the image of gamma with respect to S4. And this part of gamma is the image of gamma with respect to S1 and with respect to S1 composed with rotation by 2 pi divided by 3. Yes? So we write it. we define the rotation by 2 pi divided by 3 this way. Yes? And write the tree is that gamma is S1 union S1 R gamma union S4 gamma. Yes? This equation will give us gamma. And this equation gives us the whole main tree of this dendrite. Okay? Can you construct it? So Friday is 11:12, 12:1 is invited talk, 2 to 3 one more lecture and one more tutorial today. Okay, do you have questions? Yes. S4 is this. You see, it's not convenient to write this expression. Yes, for our use, we define S4 like this one. Oh, no. S4 is SIM, yes. No. S4 is, sorry, S4 is this map. This is a map which sends this triangle to central triangle. Yes? Did I answer your question? What? S1 is Q. S1 is Q. S2 is 1 minus Q 0 multiplied by Q. S3 is equal to 1 minus Q divided by 2. 1 minus Q divided by 2 square root of 3 multiplied by Q. Multiplied, it means we print a star. So did you succeed? Oh, that's wonderful, and you found it. So you need to construct a composition of K and its main tree. Yes, it's perfect. Okay, so there are people. success? Oh, yes, yes. Oh, no, you have the dendrite, but not main tree. Okay. And did you find your mistakes? Oh, it's discontinuous. Discontinuous curves, it's very interesting. Can I... one minus... So, oh, no. It's discontinuous, the whole object is discontinuous, or this is a tree.
Yeah.
Because k is okay. No.
This G is okay. G. I think.
This is G. No, G is... No, G is... you mean which except? Oh. Very interesting, yeah, this. This is from curve, this is I don't know what, but it is good. K11. This is yes, I understand what it is, and I don't understand what it is. G1 I 20 02 22 11 multiplied by G. Sorry, 1/3. It's okay. I 00 20 02 22 11 multiplied by G. It's a mystery. Everything is okay.
Where is the mistake, sir?
No. You know, to find a mistake, it is much more difficult. But it doesn't. Let me once more. 1/3 multiply by I. Maybe it doesn't like I. Okay. Let us write 0 0 0 0. Maybe it's some kind of personal reply. Oh.
So it's not finished. That's what it is.
That 3 is 1. Yes. But you cannot apply it. I need to check this one. So can we comment it? Okay. I forgot how to comment. Okay. It's not good when everything is. So can you finish S3 and then I will check. Yes. Okay. So main tree is yes. Oh yes. Fantastic. It's fantastic. Okay. And now it is 12, right? Friday? It's 12, we need to finish. Because at 12 I need to begin my talk for the faculty. I'm very sorry. But you can stay here and do what you like.